Hello, everybody. Welcome back. Today we're looking at synthetic division. Now, synthetic division works best for certain type of division problems. When you look at the divisor, if the divisor is in the form of x plus a or x minus a, those are the perfect candidates for synthetic division. Let me go ahead and give you a quick example. Let's say I have the following polynomial here. 3x to the fourth plus 5x cubed minus x squared plus x minus 2 divided by x plus 2. Now, the divisor here, guys, is the x plus 2. Now, because x plus 2 is in the form of x plus a, this is the perfect candidate for synthetic division. So how do we do synthetic division? By the way, the word synthetic means fake. So in other words, you're doing fake division. So when you do synthetic division, you're carrying out the process without all the variables included in there, unlike long division where you must include the variables. So here are the steps to completing synthetic division. Now, number one, you have to find the value of the divisor. Now, remember guys, the divisor is basically what the polynomial is being divided by. So the divisor lands in the denominator. Essentially, you can't have 0 in the denominator. So the value of the divisor is that number that makes the denominator equal to 0. Or better yet, just take your divisor, set the divisor equal to 0, and solve. And solve it out. Okay? So for example, if you have x plus 2 as your divisor, you would set it equal to 0 and solve. So you get x equals to negative 2. So the value of the divisor would be negative 2. Likewise, if you had x minus 3, set it equal to 0 and solve it. So the value of the divisor would be positive 3. All right, so that's the first step, finding the divisor. Now, once you find your divisor, step 2 is to go ahead and set up the problem, the layout of the problem. Okay, so your divisor goes inside. This is just setup, guys. Okay, your divisor goes inside this backwards capital L. This is one way of saying it. Or you could do a forward capital L, such as this. Now, it doesn't matter which technique you use. It all works out the same. The goal is to get to the quotient. So for this one right here, guys, I am going to go ahead and go with this format right here. And then we're going to go ahead and fill in the coefficients of each term of the polynomial. And then what you're going to do is to go ahead and leave some blank space right here, blank space, okay, and draw a line. And then you're going to carry out your process. Now, be careful, guys. If you're missing a term, a power, you're going to have to fill in 0 for that missing term or power to hold its place value. So fill in 0 for any missing term or power. All right. Now, the process for synthetic division is this. First, you want to bring down that first value. Next, you're going to multiply by the divisor. Once you multiply by the divisor, whatever the product turns out to be goes above the line, okay? Goes above the line. And then you're going to add and then repeat the process until you're done, all right? So I think I'm going to pause here before I get to step 4. and actually show an example so you guys can get a better understanding of what's happening with this. So here's the polynomial I showed you earlier. 3x to the fourth plus 5x cubed minus x squared plus x minus 2 divided by x plus 2. By the way, this one right here is a fourth degree polynomial. Because you're dividing this, division reduces something, okay? Reduces something. So because you're dividing x to the fourth by x, eventually this is going to become a third degree polynomial, all right, when you find your quotient. So guys, here's the setup. First and foremost, what value makes the denominator 0? What number plus 2 makes the denominator equal out to 0? Or better yet, you could just go ahead and take x plus 2 on the side, set it equal to 0 and solve, so you would get -2. Now, you want to list the coefficients of each term of the polynomial. The x to the fourth has a coefficient of 3. X to the third has a coefficient of 5. X squared has a coefficient of -1. Be careful with those negatives. X has a coefficient of 1, and then the constant term is -2. Now you want to leave some space and draw a line, okay? And then you're going to carry out the process. So the first step, guys, is to bring down that first value below the line. Now, you're going to take that 3 and you're going to multiply it by the divisor. Multiply it by the divisor, okay? So 3 times -2 gives you a -6, and that -6 ends up right here above the line. Now you add. I like to put the addition symbol here just as a reminder. We are adding, okay? People tend to forget, so I like to put it there, okay? So 5 plus -6, that's a -1. Now, you're going to repeat the process. Repeat the process all over again. So guys, here comes the next part. We're going to take that -1, multiply it by the divisor. We're going to take -1, multiply it by the divisor again, okay? So -1 times -2 gives you a +2. You add, you get 1. And then 1 times -2 gives you -2. You add, you get -1. Repeat the process. -1 times -2 gives you +2. You add, you get 0. That is beautiful. All right. So now we can move on to step 4, which is the last step. And step 4 is simply to go ahead and incorporate the variables, because we did this without the variables. So now we have to go back in and plug in the variables. Now remember what I said earlier, this is a fourth degree polynomial. So when you carry out the division process, it's going to reduce this fourth degree polynomial down to a third degree polynomial. So we're going to start filling in the variables, starting with a power less than or degree less than the original polynomial. So it was a fourth degree polynomial. Now you're going to start off with a third degree polynomial, okay? So x to the third followed by x squared followed by x. You've run out of x's. So you stop writing your x's, and now it's time to write your quotient. Here, let me write this word down for you. So the quotient for this one right here, guys, ends up being 3x cubed minus x squared plus x minus 1. And there you go, just like that, we are done, guys. So I did not write down step 4, so let me write it down for you. Step 4 is this. Okay, you're going to write the quotient, and when you're writing the quotient, you want to go ahead and fill in the variables. And then once you're done filling in the variables, you want to go ahead, you know what, let me put a side note over here. Side note, start with a degree or power less than the original polynomial, okay? So hopefully this helps. Right there, all right. Now guys, be careful. every once in a while, you will have a remainder. If there is a remainder, the remainder always goes over the divisor. Always write your remainder over the divisor. And then, of course, if you don't have a remainder, the last digit in the synthetic division process will be 0, indicating you have no remainder, so there's no need to put it over the divisor. Guys, synthetic division is a very simple process, but you got to know what you're doing. So I'm going to go ahead and do 2 more examples, and then I'll leave it there. So here comes the next one. Now, this next one right here, guys, you got to be careful with it because there's a term missing. So number 2, we've got 3x to the 4th plus x cubed minus x squared minus 2. And I'm going to take this one and divide it by x minus 2. All right. So first, we need to find the divisor, the value of the divisor. What number minus 2 makes the divisor equal to 0? That will be positive 2. Now we got to fill in the coefficients of each term of the polynomial. So the coefficient of x to the 4th is 3. The next power down should be the 3rd power, and its coefficient was 1. The next term down is x squared, its coefficient is negative 1. The next term down should be x, but x is missing, so you fill in 0 to hold its place value, and then negative 2. This is critical, guys, for you to fill in the placeholder. Very critical. All right, so now we have the setup. We're ready to go ahead and carry out the process. So drop that first value below the 9. Then you multiply 3 times 2, the divisor. You get 6 that goes above the line. Don't forget you're adding. 1 plus 6 gives you 7. 7 times 2 is 14. You add, you get 13. 13 times 2 gives you 26. You add, you get 26. 26 times 2 is 52. You add, so you get 50. Now, obviously, we have a remainder. So now it's time to go ahead and fill in those variables. Don't forget, the remainder has to go over the divisor. So we're going to start off with x to the 3rd, move forward in descending order of powers until you're done, you run out of x's. Once you run out of x's, it's time to go ahead and write out the quotient. So the quotient for this one is going to be 3x cubed plus 7x squared plus 13x plus 26, and then plus the remainder of 50 over the divisor, x minus 2. So yes, guys, all of this would represent the quotient to the problem. And so once you get the hang of it, it takes about 3 problems, 3 examples for you to get the hang of it. Once you get the hang of it, guys, it's a piece of cake. Seriously, very easy in comparison to long division. The long division process, guys, is just like what it sounds. It's long, very long. All right, guys. So here's the 3rd and last example. X to the 5th minus 1 divided by x minus 1. So here, once again, we're going to set this up by first finding the value of the divisor. What number minus 1 makes the divisor 0? That will be a positive 1. Now, guys, again, this one right here is missing some terms. It's not just missing one term, it's missing several terms. You have x to the 5th, and then you go all the way down to the constant. So we're missing a lot of terms on this one, okay? So x to the 5th has a coefficient of 1. The next term down should be the 4th power. It's missing, so fill in a 0 for it. That represents x to the 4th. The next one down should be x to the 3rd. It's missing, so you want to fill in a 0 to hold its place value. Next one down should be x squared. That's also missing, so fill in a 0. And then the next one down should be x. That's also missing, so fill in a 0 to hold its place value. And then last but not least, the negative 1. So now you have your setup. You're ready to go ahead and carry out the process. Drop the 1 and multiply. 1 times 1, that's 1. we add, we get 1. 1 times 1 is 1, we add, we get 1. 1 times 1 is 1, we add, we get 1. 1 times 1 again is 1, we add, we get 1. 1 times 1 for the final time. Oh my goodness, we get 0. Now, because you're ending up with 0 as the last value, there's no remainder. And so now it's time to go ahead and fill in the variables. This was a 5th-degree polynomial. So when you start filling in the variables, you want to start with the power less. So you're going to start with x to the 4th, move forward in descending order of powers until you run out of x's. And so time to write the quotient. X to the 4th plus x cubed plus x squared plus x plus 1 represents your quotient, guys. And just like that, we are done. All right. So guys, until next time, bye.